Hello and welcome. This is Lita Downs from the Center for Faculty Excellence, and I would like to welcome you to one of our Summer 2020 National Faculty Meeting Breakout Series sessions. Today's session is on data visualization for all ages, and our presenters today are Dr. Martha Larkin, who is with the College of Education and Leadership, and also Dr. Dick Larkin, who's with the School of Public Policy and Administration. We're very happy to have them on the line today for today's recording, and I will turn things over to Dr. Martha Larkin. Welcome.
Thank you. We are happy to share today some information with you on data visualization. It's a topic that we have been interested in and working with for several years. And we always like to share that information with others in hopes that it will pique their interest as well. So when we talk about data visualization, it is presenting data in graphical or pictorial format. And it can be used regularly to help us make decisions and have all of the needed information in one place. When we use data visualization, it's really important to remember to use both images and words for emphasis. That will help us to accomplish our goals quickly and easily. And one of our goals is to gain understanding of the data and also to communicate information about the data with our audience so that they will understand. We all love a good story, so data can help us tell a story, and in our planning data visualization, keep in mind the storytelling aspect. And a benefit of data visualization is to help us focus on what is important and to convey a meaningful message to the audience. We have so much technology now that we have access to a lot of data, and we certainly don't want to drown in data. We want to pull out and focus on what is important. So the data visualization can help us to do that. Next slide, please. When giving any presentation, it's always important to keep in mind the audience. And so our presentation is titled Data Visualization for All Ages. That shows the importance of knowing who your audience is and keeping that in mind as you plan and deliver your data visualization. For the most part, audiences can be quite diverse regarding their knowledge, abilities, skills, experiences, and so on. And particularly in today's times, we want to start data visualization even with young children, school-age children, young children. We may even have some at home that we can share some data visualizations with, as well as through the ages in adulthood and in any age. Next slide, please. We'd like to share some information about creating or evaluating existing data visualizations. Just like the internet, we know there's a lot of good information out there, but there's some that may not be quite as good. So it's important to know some data visualization principles and techniques to help us if we're creating our own visualizations or if we're evaluating existing ones. When we look at content, we've already mentioned that it's important to think about to use both images and words to convey the message. We've all heard the old saying, a picture is worth 1,000 words. Well, that may be true for art, but not necessarily for data visualization. Because with data visualization, you want your audience to get the same message. So it's important to use words with the images, but use as few words as possible in order to convey your message. Design principles are also important. Graphical integrity, we want to avoid distortion. So we want to make sure data that we are representing are in proportion and also that they are clearly labeled. Another tip is if you are using data over time, that you want to use equal time increments. For example, if you wanted to use everything in 1-year increments or everything in 5-year increments, but you wouldn't want to combine both of those because it would lead to distortion. Another tip is to always provide a context for the data to aid understanding. We've talked about stories a little bit, so when planning data visualization, keep in mind that you are telling a story. Good stories have a beginning, a middle, and an end, and keep the audience informed along the journey. It's important, too, to pay attention to details, particularly formatting things such as color, shape, direction, complexity. For data visualizations, when we're talking about color, we want to use color sparingly, and remember that bright colors are not easily readable. If we think about something that we see probably just about every day that we go outside, something as simple as a stop sign, think about the role that color and shape, along with that one simple word, stop, play in identifying a stop sign when we go by it. A stop sign definitely gets your attention. And then finally, technology. Think about using the technology that you have available to you. Think about what might be the best fit for what you're trying to accomplish. Think about expertise that you have. And certainly you might want to increase your expertise. There are a lot of resources available. So you might use things such as your Microsoft Office, your Excel that you might have available to you, or you might explore some new resources, some free online resources. So next, Dick will share some innovative techniques for data visualization.
Thank you, Martha, and thank you for viewing our presentation. The slide I have here illustrates a type of data visualization that I've been noticing used recently in the New York Times. The technique can be used in place of a pie chart to illustrate different segments of a population. The topic discussed on this slide is the number of people needed to be exposed to achieve herd immunity to the COVID-19 virus. Since we probably have some people from the health sciences on this call or on this presentation, I will confess ignorance about the actual percentage of the population that would need to be infected to achieve herd immunity. I'll simply rely on a recent article I read that claimed we could reach herd immunity when 60% of the United States population had been exposed. The pie chart at the top of the slide illustrates the traditional method of illustrating this concept, saying we have about 57% people exposed compared to about 43%. We'd know we would need to expose about 3% more of our population to achieve herd immunity. The two pictures on the bottom of the slide illustrate a new visual to represent the same concept. The circle on the bottom of the slide the circles on the bottom of the slide have emojis of two different colors. The black emojis have been exposed and therefore they're safe. The red emojis have not been exposed and therefore the red indicates they're still in danger. The circle on the right shows how many people represented by an emoji would need to be colored black before we could achieve herd immunity. The circle on the left shows how many people have been recently exposed to COVID-19. As you can clearly see, we're quite a ways from achieving herd immunity. I think this method of presentation is very good in getting points across as the one I'm trying to represent with regard to herd immunity. I think this is also a very good technique to use with younger audiences because it allows them to visualize rather than have to interpret a chart. Next slide, please. The second innovative technique I will discuss is three-dimensional virtual reality. Some of you listening to this presentation or viewing this presentation may be familiar with some of the virtual reality applications that Walden uses in their classrooms. The visualization on this slide were used a number of years ago by a colleague of mine and I, who were tasked to evaluate a large PT3 project. For those in the College of Education, you're familiar with PT3, the Preparing Tomorrow's Teachers to Utilize Technology. We were looking at barriers that prevented college faculty from using technology. We also wanted to identify strategies that would help overcome those barriers. We did our research, we did our literature reviews, and we came up with hundreds of barriers and hundreds of strategies. We then chose to connect those barriers to the strategies that would be most likely useful in helping overcome the barrier. When we did this, we wanted to graph this out to see what it looked like. And when we made our graph, it looked like the representation on the left-hand side of the slide. If you look at that, you can't make out very much of any detail or anything about it. It's a total confusion. So in order to overcome that confusion, we took that same data and went to a cave automatic virtual environment, which is the use of a lot of projectors and a lot of mainstream computing power to create a three-dimensional virtual reality world of our barriers and strategies. Then the user of our research could put on the goggles and actually go to a barrier and walk to a strategy that would help solve that or help overcome that barrier. The distance between the barriers and the strategies in some respects represented how closely related those strategies were to that particular barrier. Now, this required a great deal of technical and computing power to do this three-dimensional model I've displayed on the screen. But since the time we've done this, or did this presentation, laptop computing, software, and peripherals for laptops and desktops has improved so much that you could make a presentation almost identical to the one I have on the page here from your desktop. If you're interested in this, if you'll drop me an email, I will give you some references to some YouTube videos and so forth that you can watch with regard to how to create these types of representations. Next slide, please. The third innovative technique I want to discuss is geographic information systems. Almost all data have geographic or geospatial components. And geographic information systems, or GIS, provides a means for displaying those geospatial components of your data. The slide I illustrate with here is a research project that my colleague Sal Peralta and I did after the 2010 census. We were interested in discovering where there were large populations of Latino or Hispanic populations throughout the southeastern United States, and then trying to determine what impact they might have on the redrawing of representative congressional boundaries in the upcoming redistricting of various states. The chart on the left shows the counties in Texas that have the largest concentrations of Hispanic population. And that is a good chart. It tells you a great deal about the counties and where their total Hispanic population, but it says nothing about where they're located. By putting this information into a geographic information system, pushing a few buttons, we produce the map on the right-hand side of the page, which shows us that the large concentrations of Hispanic population are in the southern part of Texas and over in the western part of Texas. So we can concentrate our analysis and our interest to those areas of Texas. If you're interested in GIS, which has a broad applicability across all sorts of fields of study, everything at Walden, it's applicable to education, business, health, and social sciences, all can use GIS. And we have, in the School of Public Policy and Administration, a 3-course graduate series and a certificate program in GIS. The courses are designed so that the first course talks about data structures and mapping and where to find data and very general things about geospatial data. The second course is more technical in nature and actually shows you how to use the software that I use to produce this map. And then the third course is designed specifically for people to use their area of interest to pick a project and then use GIS to do analysis and display of their findings. So if you're interested in this, once again, you can drop me an email and I'll be happy to discuss it further with you. Next slide, please. My final innovative technique is not that new. However, I think it's still innovative because it hasn't been used that frequently. It's called sequential thematic organization of publications, or STOP method. The method was pioneered by Hughes Aircraft in the mid-1960s. Hughes was writing proposals to the Department of Defense to conduct very sophisticated research and development of electronic radar and other systems. What the Hughes people found out was that their engineers were writing the proposals in highly technical terms, but the people that were reviewing the proposals did not understand engineering. They were accountants or grant managers or something like that without technical expertise. And so Hughes wanted to find a way to convey what the information they wanted to get across to non-technical audiences. And so they started doing some research and they came up with the STOP method. The STOP method is based on the principle that if you're having multiple writers, you could do a storyboard and arrange everything you wanted to say in your document into major and minor topics, major topics and subtopics, and place those on a storyboard in sequential order. Each topic should be about 500 to 1,000 words long. Hughes research showed that that's about the attention span most readers have when they're looking at text. Now, the traditional text would be presented like the slide I have at the top there, like the illustration I have at the top of the slide. In a STOP method of publication, the text data would be presented on the left-hand side of the page. A graphic illustrating and complementing the text would be presented on the right-hand side of the page. Every time a reader turned a page, they would encounter a new topic. They could read about that topic, and then they could look and gain additional information from the graphic regarding that topic. With traditional printing methods, this was somewhat difficult to do, but with laptop publishing now and inexpensive and high quality printers, I've been able to produce documents like the ones you see here on my own little laptop sitting in my desk at home. I first became acquainted to this technique when I was working with some people who were trying to convey information to first responders who would go to an incident at the Savannah River nuclear power plant. And most of those first responders were volunteer firemen who had a high school education or slightly more, but not a whole lot more than a high school education. And they were trying to figure out ways you could explain nuclear power generation and nuclear physics to firefighters with high school degrees. And they came up with this STOP method of doing it as a way of producing procedure manuals for volunteer fire departments who would be the first responders to a nuclear disaster. And since I have not heard anything about a nuclear disaster at the Savannah River nuclear power plant, I assume their experiment has worked so far. Next slide, please. We think that telling stories is extremely important. It's a powerful way of conveying research. It's a powerful way of teaching, and it's a powerful way of communicating all sorts of data to everyone. We think that a good presentation using images and words makes for a very memorable story. And so we hope you've enjoyed our story, and we hope you've gained some information from it. And I've left you my name and my email address and Martha's name and her email address on this slide. We would be delighted to hear from you, have your reactions to our presentation, and hopefully answer any questions that we might have from you. Thank you for your time and your interest. Have a good day.